Instrumental texture profile analysis, that is TPA, is a 2 cycles compression and decompression on a bite-sized sample of 1 cm³ by a plunger. I have a dead fruit. I remove the pit and I am going to eat. What I have done: first biting, then chewing, then masticating, and then swallowing. In this process, dead fruit was broken down and disintegrated into small particles and mixed with saliva. Why? It was easy to swallow. Finally, what was my residual feeling? Now I am assessing what was my tactile feelings in this process when taste, odor and flavor are excluded. Can we assess these tactile feelings by an instrument? Yes, we could do it to some extent using an instrumental texture profile analysis, commonly known as instrumental TPA. Please keep watching this video until the end and you will find more about it. And if you like this video, then subscribe to our channel. A special thanks to Engineer Rashid Al-Baluchi for helping me in developing this video. Actually, TPA mimics the biting and mastication process of food inside our oral cavity. It applies 2 cycles, compression and decompression, to explore the structural characteristics of food. In this video, I am going to explain the basic understanding of instrumental texture profile analysis, that is TPA. I will explain how to measure fracturability, hardness, cohesiveness, adhesiveness, springiness, chewiness, gumminess, and resilience. In the first slide, we have seen the 2 cycles compression and decompression for apple cube. In this slide, we could see the 2 cycles compression and decompression of dead fruit. Sample was placed on the center of the base table. We also need to set the experimental conditions in the TPA software. First cycle compression and decompression. Second cycle compression and decompression. The force time or force distance graph is automatically shown on the computer. First cycle completed, holding, second cycle completed. We need to use this TPA graph to determine different TPA textural parameters to characterize the sample. These characteristics could also be related to the sensory texture measurement by test panel. Interpretation of the TPA graph needs to be understood, and it is important to define the instrumental textural attributes. In this graph, we could observe first cycle compression and decompression, that is force time curve, and downstroke or compression cycle and upstroke or decompression cycle. Then holding time, that is duration gap between first and second cycles. After holding time, we could observe the second cycle compression and decompression force time curve, and downstroke or compression cycle and upstroke or decompression cycle. Using this graph, I am going to explain fracturability, hardness, cohesiveness, adhesiveness, springiness, chewiness, gumminess, and resilience. Fracturability is the force at the first break in the compression of first cycle. It is marked as S1 and the unit is Newton. Hardness is the peak force of the first compression-decompression cycle, that is force necessary to attain a given deformation. It is marked at maximum force F1 and unit is Newton. Therefore, hard material is difficult to deform, that is needs more force as compared to a soft material, and soft material is easy to deform. For example, nuts are hard while dead fruit is soft. Cohesiveness is the ratio of the positive area of the first cycle to the positive area of the second cycle, that is cohesiveness equal to A2 by A1. It indicates the strength of the internal bonds of a food and unit is dimensionless. In the brittle materials, cohesiveness is low whereas hardness can be varied. Adhesiveness is the negative area of the first cycle, that is A3. It represents the work necessary to pull the compressing plunger away from the food surface. Cohesive force is within a food, while adhesive force is on the surface of a food. In this slide, we could observe the cohesive and adhesive failure. First, cohesive failure and second, adhesive failure. Initially, springiness was defined as the distance of the second compression of the second cycle. It is a recovery after the first cycle compression and decompression, that is D2, and unit is meter or second. Later, springiness was commonly defined as the ratio of the distance of the second compression of the second cycle divided by the distance of the first compression of the first cycle, that is D2 by D1. Therefore, springiness is the ability of a food to come back to its original size and shape. We could understand the springiness in this slide. We could have first cycle compression and decompression and then second cycle compression and decompression. Now we can see D1 and D2 and we could calculate springiness as D2 by D1. Chewiness equal to hardness times cohesiveness times springiness. Chewiness is the energy for masticating a food until it is ready for swallowing. It is mainly for solid foods. Gumminess equal to hardness times cohesiveness. Gumminess is a measure of the force to disintegrate the particles ready for swallowing. It is only applied for semi-solid foods. Resilience is the area under the curve after peak force is reached during first cycle divided by the area under the curve before the peak force is reached in the first cycle, that is resilience equal to A12 divided by A11. It is the ability of a food to fight back. I would like to give a brief historical development of the instrumental textural profile analysis, that is TPA. The breakthrough in instrumental TPA came with the development of the General Food Texturometer. In 1963, in an attempt to simulate mastication, a group led by Dr. Szysniak developed the two cycles compression and decompression by texturometer. In the late 1960s, the major milestone was achieved when instrumental TPA was adopted by Instron Universal Testing Machine. Recently, modern computer-assisted TPA provides great versatility. It is important to know how to prepare a sample for TPA and what operating conditions need to be used. In another video, I am planning to include what are the factors affecting the instrumental TPA. It is a challenge to correlate the instrumental TPA with sensory TPA, although it is relatively easy to measure the instrumental TPA attributes. In addition, there are correlations between the TPA attributes. Then question is, what the key or significant attributes need to be considered to determine texture of a food. I would like to thank you for watching this video until the end.